Let me bring up my screen. All right, hopefully everyone can see that. And please, as we were saying, use the Q&A. My name's Sheppard. I'm a customer solutions engineer at Palo Alto Networks, and predominantly my focus has been on SASE and helping our customers sort of transform their networks and their mobile users and their connectivity into cloud, into data center, and really provide a consistent network and security experience. But with that being said, right, today predominantly is focusing around SD-WAN. And so what Byron and I wanted to do was sort of provide an evolution of how Palo Alto has seen the growth of SD-WAN, why we have the two solutions that we have today, and then somewhat of a comparison and why we see the need for these two solutions and how customers are using them within their environments. So getting into that, I think it's important to sort of talk around the evolution and sort of my picture of SD-WAN and where it's gone over the years, right? If you look at the evolution of SD-WAN, we've really gone from this traditional approach 10 years ago where predominantly applications lived within the physical data center. Heavily used MPLS, lease lines, customers predominantly were looking to try to get back to their data center over these private infrastructures to consume those applications. Lo and behold, SD-WAN comes out, right? The ability to really accomplish hybrid WAN became the main goal. How do I reduce the cost of MPLS? How do I start leveraging broadband internet, which is becoming a commodity, and bring availability and start leveraging that to offload costs? But with that, and I'll call that sort of the generation one SD-WAN vendors, which there are a lot out there. There's been an evolution, and COVID has really sent this, off into the stratosphere with the evolution of SASE, right? Secure Access Service Edge, where now we're seeing a fundamental transformation of where applications live. So no longer do applications just reside within the data center. Predominantly now we are a hybrid cloud environment. SaaS is becoming ever so important. And in many ways, COVID has forced us to look at connectivity in a much different way. So we were mobile, now we're hybrid, and we're probably going to be hybrid for the foreseeable future. And how we accomplish that is much different from what we looked at a couple of years ago when we looked at what SD-WAN was there to provide. So the reason I bring this up is because SD-WAN might mean something different to every one of you out there, right? SD-WAN might mean a hybrid WAN approach. Maybe your goal is reducing your cost when it comes to MPLS. But what I've seen is SD-WAN can do a lot more than just that operational cost of circuit complexity, right? There's also the cost of operating, of maintaining that infrastructure, the flexibility for how it gets rolled out, how it gets managed, what capabilities you can bring to bear, right? What is the security posture? And as you start to look at a world where applications reside in the cloud, you might look at moving towards thin branch approaches. So just like that, right, where customers have different initiatives, different projects, different goals, Palo Alto has different solutions to accomplish those tasks, right? So we have PAN-OS, and then we also have Prisma SD-WAN, which was made from an acquisition of a company called CloudGenix. And so those two solutions, right, fit different requirements that customers may need. And so that was one of the main drivers and the reasons why Palo Alto went out and acquired CloudGenix is because they saw a shift and they saw a need for a different type of deployment and operation model that fit into their goals of a cloud adopted world, right? But that doesn't mean that firewalls are getting replaced in every location and everywhere, right? The physical firewall still plays a major role, but the ability to have both fits the needs and fits different projects, initiatives our customers might have. So what I'm going to do is spend the next couple of minutes here talking around Prisma SD-WAN, right? The evolution of CloudGenix and how it fits into the portfolio. And then I'll hand it off to Byron, who will talk about PAN-OS SD-WAN and the capabilities with that solution and how it fits into our portfolio. So for those you don't know, Prisma SD-WAN is the rebranding of CloudGenix, right? CloudGenix was acquired 2+ years ago. And I think, Palo Alto saw the shift, right? We saw the need for SASE, the growth of SASE, And being able to have a true cloud-native SD-WAN solution that would provide the on-ramp and a true full-blown SASE solution was extremely compelling and the reason for the acquisition. Since then, there has been huge strides to not only rebrand that, but tightly integrate that with our Prisma Access solution to provide a true SASE, which is the consolidation of network and security as a cloud-delivered resource. So if you look at SD-WAN, Gen 1 vendors, when we talk about moving towards that hybrid WAN, there were still a lot of difficulties they struggled with. In many cases, it was taking an additional router or a firewall, some capability, and adding in some intelligence around how we did forwarding. But for the most part, those are all still packet-based systems. They look at layer 3 policies, and they have limited understandings of the apps in terms of the network performance, right? Maybe they can understand from a security perspective, but how they handle the network performance with each individual application was limiting. In addition to that, many of the solutions, right, took a CLI-based approach or an approach where it was bolt-on configurations or APIs that made the deployment and the operation of them extremely challenging, right? How do we roll these out? How do we maintain them post-deployment? How do we interact with those systems when changes need to be made? Additionally, we have bolt-on complexity, right? So as a cloud-delivered solution, right, we have the flexibility of really bringing new features to bear at rapid growth, but many of the other vendors out there, right, the difficulty is how do I add new features and capabilities, right? Does it require additional modules? What sort of things do I have to deploy on-prem to make that happen? So, when we talk, SD-WAN, Gen 1 and Gen 2, really we're talking about the evolution of these components into that next-gen SD-WAN phase, a true SASE-based approach where we can dramatically help to resolve these problems outside of just providing hybrid WAN capabilities. So with Prisma SD-WAN, if I look at 3 main areas we are trying to help solve and really accelerate is first, the application-defined network. Right? We want to simplify routing complexity, and really we want to steer traffic based on an application definition. That application definition is going to give us visibility to drive policy, path, security, quality of service across the board from my network, right? So not longer just looking at a layer 3 routing perspective, but looking at layer 7 application information, being able to leverage that to make intelligent path forwarding decisions and really drive this autonomous WAN where we can have a self-driven, self-healing network based on your application definitions. The second piece, being autonomous in nature, right? Not only from the deployment of how we get these systems out there up and running, but being able to leverage machine learning, data science for configuration and troubleshooting capabilities. Often what's missed when you're looking at products or looking at SD-WAN is once it's deployed, right? Outside of just the ability to steer traffic is how does it handle ticketing, right? How does it handle event correlation? What about intelligence on things that are going on with the network that could bring to light, that could foresee problems that are going to happen within the network, right? Those sort of capabilities really become key in how you can save from an operational complexity and a cost perspective. And the third piece, cloud delivered, right? With Prisma SD-WAN, it's a cloud delivered approach, right? And being able to add features and capabilities directly onto that cloud architecture without really going in and having to do forklift hardware upgrades or additional modules on-prem, right? A cloud delivered branch from our system and integrating in with other third-party applications that you might see fit, such as ServiceNow or Teams or Zoom. Things like that that can help deliver additional features and capabilities to you. So if we break those apart, right, we'll look at each one individually, but to bring this together, right, is that Prisma SD-WAN is more than just an SD-WAN fabric, but it's really an evolution to our SASE approach, right? So with Prisma SD-WAN, it provides our SASE fabric that gives you connectivity not only to your branches and your data centers, but integration into Prisma Access to consume all the security services from Palo Alto as a cloud delivered approach. Like I said, as COVID has forced us to really rethink the activity of work, right? It's not necessarily a place, it's an activity that we go do, and we might be mobile at a Starbucks in a remote location, but now we're also forced to be hybrid where we go back into these remote branches. The ability to provide a consistent experience, whether I'm mobile or within my remote branch, and a consistent security inspection from a ZTNA perspective becomes ever so critical. So Prisma SD-WAN is a tight integration with Prisma Access and provides that SASE fabric and on-ramp to give you the best capabilities and integration into that security platform. So even though I'm talking today predominantly around Prisma SD-WAN, understand that it's part of a bigger architecture on how we create the connectivity and deploy a SASE-enabled fabric. And there's continued to be tighter integration between the two to provide you those capabilities. So when I look at this, right, we do have two different solutions, and I know Byron's going to talk more towards this, but with SASE, we're really driving towards this world of a thin branch, right? Applications are moving to the cloud, right? They're predominantly not only in my data center anymore, but they're SaaS provided, they're public cloud, and I'm moving a lot of those servers and applications from my branch and into that cloud. And now my branch is becoming predominantly a user-based location, right? And being able to deploy a thin branch gives me a lot of flexibility in how I'm able to roll those locations out, how I'm able to maintain them, operate them, and get intelligence from those systems, right? All from a cloud delivered approach. And so with SASE, I'm now being able to combine not only the best of breed from a SD-WAN and on-ramp connectivity, I'm also able to provide all the security capabilities, but offloaded from a cloud scaled, cloud delivered approach. And it gives me the ability to rapidly spin up these locations, expand, retract, as well as bring new capabilities to them with a click of the button, right? With a thin branch approach instead of traditional thick based hardware. Now that's not to be said that a thick branch is gone and there never will be them anymore. There definitely are use cases where that still is in play, or maybe a hybrid approach is still a requirement. But this is where, like I said, we have two different approaches because we have customers with different goals and different initiatives that might drive them in certain paths. Some already have PAN-OS. Some of them are only looking necessarily maybe for hybrid WAN and a little more intelligent routing. And they don't necessarily require what we have from a SASE approach, where others are looking for a cloud delivered solution, right? They've moved all their applications to the cloud, right? They're predominantly user-based connectivity, and they're looking towards this new model of a SASE delivered solution. So with Prisma SD-WAN, as we start to understand some of those things that make it significantly different, is the shift from packet-based to app-based. And I talked about this a little bit, and really what I'm talking about here is understanding the connectivity of applications, right? And the fact that when I talk layer 7, what I'm talking about is additional information outside of jitter, loss, and latency to understand how those networks are performing. Many solutions look at just those components there on the left to make decisions on how applications are performing. Where in the case of Prisma SD-WAN, we're taking additional layer 7 metrics, things such as the TCP transaction time, initialization connection, Kodak MOS score, things like that to help make intelligent porting decisions based on your applications and based on the path logic you want to provide that application. So it's a very important, and you'll see within the demo later today how understanding the application, identifying it is critical because we use that information for all things that happen within the platform, whether it be a path decision to find you the best path to the resource itself, or whether it be quality of service or security from a segmentation perspective. So when we look at the SD-WAN platform from Prisma, right, it's truly an application defined where we're going to be able to write policies and not worry about routing complexity when it comes to that overlay fabric, right? That overlay fabric is going to be built dynamically, and you're not going to have to worry about the complexity of BGP, of VPN tunnels, or anything like that. The system will natively handle that for you from the cloud-based controller. And you'll be able to simply write policies based on your application definitions and what your company requires from a compliance, right? As well as from a performance standpoint. And so you'll be able to dictate based on whatever circuits you want to bring in, whether it be LTE, MPLS, broadband, and write policies to dictate how you want those applications to be handled and whether you want them to go back to your data center, out directly to the public internet for SaaS-based applications, or out to Prisma Access for granular security inspection. So you'll see how it's simple to really integrate this system and provide an application-based policy to how you want to treat those things, as well as then look at things more than just latency, loss, and jitter to be able to dictate which is the best performing path to get towards those applications. And when I talked about cloud delivery, right, the key here being is everything is going to be managed from the centralized cloud controller. Right, you will log into that cloud controller. All configuration of the system will be done through that from a zero-touch provisioning, meaning I'm rolling out the IONs, which are the physical hardware platform that we leverage within Prisma SD-WAN, to the upgrading to the configuration. It's all pushed dynamically from the cloud. But what about integrating that with other systems? Right. So one of the reasons why CloudGenix was originally purchased is because the great integration it had with Prisma Access on dynamically building the connectivity to Prisma Access. And now we've enhanced that to create this truly evolved SASE solution. But we have other ones as well out there. If you want to integrate with AWS, Azure, GCP, we have Cloud Blades that will automatically create the connectivity, deploy IONs into those environments, and do the configuration for you. Integration into things like ServiceNow. These are cloud delivered solutions with the click of the button, no additional hardware on your side, no additional containers that you need to deploy. We can integrate our ticketing system into ServiceNow to basically create those tickets based on events that are going on within the platform. So the whole idea with Cloud Blades is being able to deliver additional functionality into third-party systems without you having to deploy anything on-prem, any configuration within your environment from a virtual machine or anything like that. These are truly API integrations from our system into these vendors to really enhance the experience and the operational challenges that you might face with other solutions today. The other thing I'll mention here is the evolution of SASE and what you'll see with Prisma SD-WAN is that end user experience is critical, right? It's around the fact that the first thing that always gets blamed is the network, and even more so the security as well, and the fact that something's not working, let's turn off that firewall rule, let's disable the security, let's just go direct internet. It's got to be something with the network or from a security perspective. Now, the great thing with Prisma SD-WAN is one of the things that we are so good at is the fact that we are collecting real-time application metrics to make intelligent decisions and to give you insights into how applications are performing. But the other item that we brought on board is via ADEM. So ADEM is our Application Digital Experience Monitor. It's something that's also embedded into the Global Protect client as a cohesive SASE solution. But what the ADEM module in the Prisma SD-WAN solution does, it provides us synthetic metrics as well. So within the ION, we're able to generate synthetic metrics across our active, backup, tertiary plans, paths back to your data center in real time for any applications that you want to monitor. The great thing about this is being able to understand prior to users ever coming into the office, maintenance windows that you might have, validating connectivity, anything like that. We can leverage this information to provide you real life metrics and health scores on how that branch is performing, regardless of what the end users are actually doing at any point in time. And not only is it going to give us a score and a metric on how that application is performing from a latency and connectivity perspective, it's also going to give us underlay path performance perspectives on the ISP hops, where we're seeing latency within those ISPs. And it's going to do us this across all paths, like I said. So it's not just the active path, but it's also that backup path to understand how that would be performing. And all this data will be consolidated, whether it be from your remote branches or your mobile users, and reported within our ADEM portal to give your help desk visibility on how those users and how those remote locations are performing, and now gives you a proactive approach to understanding what your mission critical applications and how they'll be performing at those locations. Now, the last thing I'll talk about here, which to me is probably one of the most compelling things and something that I get the most excited about, just because I think the operational complexity of these systems and the data that we can start to leverage and pull from them to make our lives easier is extremely compelling. Like I said, most people think about, I just want to shift off the internet, right? Get off MPLS. But being able to really simplify the operational experience and then provide insight into what's going on and how we can leverage the data we've already gathered becomes critical. So AIOps is something we've been working heavily on, and you'll see continued evolution around this. But the ability to observe, engage, and act becomes critical. So what do I mean by AIOps, right? Well, to date, we've been gathering all this intelligence on Prisma SD-WAN, meaning we understand every single application flow that's going through your system, right? We're seeing that data, it's getting logged. We understand the performance of these applications. And so using machine learning and AI, you can start to see how we can do things like trending. So the first thing we actually did and came out is doing things with event correlation, meaning if we see an interface go down and it affects 14 VPNs, rather than say, here's 14 error codes, let's give you one error code that says an interface is down and correlate the 14 VPNs down underneath it. So starting to simplify how we generate logs and alarms to make it much easier for IT ops to figure out what the root problem is and solve that. So the idea is observing is we know these anomalies, right? We see them, we see these errors, we see these applications performing, and over time we can do different performance analysis, whether we're seeing consistent jitter or latency loss periodically, and it's coming back time and time again. We're seeing interface flaps, we're seeing specific application failures consistently, and being able then to engage support and engage people to start closing out these problems or predicting things that could become a problem. If we start to see circuits continually increasing on bandwidth from a week-to-week perspective, maybe 1 or 2%, we can start then predicting when we're going to have circuit issues because we're going to start running out of bandwidth. So the whole idea here is leveraging that intelligence. And since we've got a cloud-delivered model with this central controller where we're seeing all this information, right, we're looking at ways to observe, right, then engage users, and eventually the idea of automatically reacting to those problems, right? If we see configuration errors that we know are wrong, being able to automate and remediate those, right? We've already developed this self-driven healing WAN, but maybe even then providing insight to when critical applications are shifting paths that you might want to know about that. So this is sort of a crawl, walk, run phase, right? And we're very much in the middle of this, and you'll continue to see evolution of how we're engaging AI ops to really make your life easier from an operational perspective of when you get into that system for it to be able to bring you insights and bring you information that's invaluable to you around what trends are happening with the network and where you should engage and act with your time. So that being said, I'll pause there for a second. I'm going to hand it off to Byron, and I will look at some of the questions that were there within the chat, and I'll definitely answer them, and we can definitely have a discussion towards the end after that. But Byron, I'll hand it over to you here for a few minutes to talk around the PAN-OS side.
All right, thanks, Ram. Are you going to continue sharing your screen?
It's up to you. Do you want to share? And I can answer some questions. Cool.
Yeah, sure. Alrighty, so Byron Inahara, I'm a senior global consulting engineer. I own SD-WAN, HA Performance, and I've been working with our pre-sales group since we introduced SD-WAN about 2 years ago in 9.1. Let me go ahead and share this real quick. All right, can everybody see this? Let me start from here. All right, so to continue on from how Graham was explained SD-WAN progress and things in general, what I want to do is how do we introduce PAN-OS to SD-WAN? Or SD-WAN to PAN-OS, right? So if we kind of look at what we've had before 9.1, you still have your traditional firewall at most of your branch locations, right? So how we introduce SD-WAN to PAN-OS is that we take that approach of having a firewall at all your different locations. But prior to bringing in the SD-WAN logic into PAN-OS, you had your typical upstream router, right? So you had the firewall in there protecting your network. We would forward it to the SD-WAN next-hop router, and then the SD-WAN router would make us path decisions, right? Typically on digital latency and packet loss. So there's different flavors you could do that to, where you had hardware firewall, hardware router. You could do the VM series firewall within that SD-WAN router, right? Both of them could be VMs. So what we've done here is actually brought in the whole SD-WAN logic within the firewall, right? The advantage is that instead of having that more generic type of SD-WAN router, which is another device in your environment, is that we brought the whole logic to the firewall, right? So Palo Alto firewalls at your edge, we can now make those path decisions. So how did we really introduce this into the flows? So what we're doing is we're taking our traditional layer 7 inspection, right, that we started 15 plus years ago. When you had your more traditional next-hop SD-WAN routers, a lot of them are still based on port protocol, right? So even though that the firewall sitting behind this router could detect different types of applications using SSL or something like that, when we forwarded to the next-hop router, it had only one choice, right? Port 443 protocol, where am I going to send it? It didn't know if I could send it through an expensive path or a cheaper cost or things like that. So by bringing in the SD-WAN logic within the firewall, we're now using our layer 7 inspection, right? A lot of those generic SD-WAN routers, yeah, they're catching up. They're doing application detection, but a lot of it's still based off of web, URLs and things like that. So for us with the SSL and other things that we take our app ID, we're able to do everything we've done in the past, right? We didn't replace everything. What we've done is we have better monitoring. If you think about our SD-WAN, I kind of break it into two pieces. One is our SD-WAN logic, is how we can make those path decisions, right? We can make it by quality, by cost, or things like that. Second part of it is how we can deploy this easily for you, right? We're going to make it very cookie cutter, and we're going to make it where you can deploy 1 to 10,000 sites very easily, right? So within Panorama, we put in this auto VPN to kind of configure everything and help with that deployment. SASE is going to demonstrate that later on, but I want to talk about the flow, right? So when we introduce SD-WAN, right, we've already had multiple path failovers. We've had that probably a good 12 plus years. But what we had with these path failures is we had to have that complete outage, right? So you're gonna hear terminology, blackout and brownout. So prior to SD-WAN, we had to have the path completely go down, right? We already had heartbeats we could send out. We sent out 3, as long as we got one of them, we know the path was good. So prior to SD-WAN, a lot of customers had MPLS, and they would have their DIA backup, right? But it's really based off of routing and host monitoring. So I can monitor something within that path. Well, if you had high latency or packet loss, as long as I got one of those heartbeats back, right, we would still say the path is good, and we would still continue. We wouldn't fail over because it was degraded, unless it was to a point where I was losing all of my heartbeats. So now with SD-WAN, what we've done after 9.1 is we brought in better monitoring. So we now send a proprietary probe, so now we can measure the quality of those connections and be able to make path decisions accordingly. So now we could fail over because of brownout conditions, not blackout, right? So what we did is this network overlay is we built everything on very mature feature sets that's been around 10 plus years, probably 12 plus years in most cases. Route-based VPNs, right? Route-based VPNs, route-based VPNs. Prior to 10.03, everything was based off of hub and spoke, right? So you also had all your branch devices, and for branches to talk to another branch, you had to talk through your hub. We brought in full mesh, which means in addition to branch and hub tunnels, right, we can have direct branch to branch. So if you had applications that can handle that additional latency with additional hops, we can now support branch to branch. And it wasn't really part of SD-WAN. It was mainly how our IPsec is working, right? So prior to 10.03, at least one side of your IPsec tunnel had to be statically addressed, right? So you can have dynamic address of one of your branch locations, but I also had to have a static address to be able to point to when I build that phase one, right? In 10.03, what we've done is we are now able to support dynamic to dynamic tunnels. And the reason why this was important for SD-WAN is you're getting away from the really expensive MPLS private connections, right? Those point-to-points, and you could get some of these less expensive high bandwidth type ISP connections. The biggest problem with those is that a lot of times they're shared resources, and certain times of the day you may get some higher latency or packet loss or things like that. But most of those inexpensive connections are going to be DHCP address, right? So you got a lot of branches that are dynamically addressed. So without knowing one of the endpoints, we couldn't build that tunnel. So in 10.03, we now support DDNS, so we can do dynamic to dynamic tunnels. And that really helps with that whole branch to branch communications, okay? So think of it, network overlay, IPsec is IPsec. We're gonna do all the heavy lifting, which will demonstrate how that gets configured, but we're not shortcutting anything, right? The heavy lifting that we're doing is it typically takes 12 to 14 steps to build a tunnel to every location for every types of connections. We're going to be able to do that very quickly. So we could probably get that down to about 4 to 5 clicks, right? And we could build 1 to 10,000 tunnels that easily, right? So that's what we're going to talk about. They're going to demo later on is that auto VPN part of Panorama. But in addition to route-based VPNs, we're using eBGP. So eBGP Trust is a tool so we could share network and routing information between SD-WAN devices. It doesn't mean you have to change your whole environment to BGP. It doesn't mean that everything has to change. This is the mechanisms that we use so our branch devices can advertise their connected networks and routes into the hub. And the hub, we can do summary routes and we can advertise those through the tunnels, right? No different than what you did in the past. If I match a route that points to tunnel interface, then it gets sent through the tunnel to the other remote location. The other thing that we've done is that because you have all of your ISP connections in most cases, right, you have direct internet access. So if you need that local segmentation, right, so you standardize on Palo Alto firewalls at each one of those locations, why not use what's available for you? There's no need to have this huge pipe to backhaul all of your traffic to your data centers or your hubs to have the internet access, right? You have the same firewall capability everywhere. You have the internet connection, so you can split tunnels. You can do your URL filtering. You can do everything at each one of your branch locations, so you don't need that huge pipe for your internal resources. You just need to be able to have a connection that can support some of those internal accesses, okay? So that's one of the advantages, right? Having that Palo Alto firewall at your current location, you're not getting another third-party device in there to do your SD-WAN logic, right? Everything is within the firewall itself that you already standardized. In addition to the eBGP pairing that we do between SD-WAN devices to share that routing information, we have a way for you to connect easily, right? We don't connect anything directly to the firewall as in ADSL, LT. We don't terminate those types of connections. But in most cases, you're always going to have that modem provided to you by your service provider. Also with MPLS, right? Currently, we don't terminate MPLS on our interface. There's usually an MPLS router, talks to MPLS upstream, talks Ethernet to the firewall. So as long as we have that Ethernet handoff, you can use multiple physical ports, right? And each one of those physical ports was a WAN connection. In 10.1, if you have some locations that have a little more advanced routing in there, and you're either trunking your traffic over or you have some bigger pipes connection between your WAN and your infrastructure, we support SD-WAN on sub-interfaces and aggregate interfaces. And that came in on 10.1, okay? So this is kind of what we've done. We've taken that network overlay, we're using very mature code, we're collapsing your external SD-WAN router, right, into that logic into the firewall, right? And then we're gonna allow you to deploy this very easily, very cookie cutter by using Panorama. So we put this auto VPN feature. So that's going to do all your configuration. It's going to build your tunnels. So you can think of it as a VPN configurator, right? But it's an easy way to deploy everything. So what we want to do is look at the flows, right? So the biggest panic when we first announced that we're going to support this SD-WAN was, oh my God, we ripped all the guts out of it and our network logic and all that stuff we're going to have to learn, right? Because everything is a network overlay on existing, your flow from how our Palo Altos work has not changed, right? Packets ingress on the interface, I know what my source zone is, I do a route lookup, so I know what my egress interface is, and I know what my destination zone is, right? And then I can look up, do I have any existing sessions, right? Look at the tuples. That has not changed. Your session setup, your NAT policies, QoS, all these different things, right? Security policy, all that has not changed. Even your content inspection, none of that has changed from everything that you've been doing day to day, right? Where the SD-WAN comes into play is at the egress. So not only are we just based off of destination routes, it's now going to be based off of policy-based routing. So in the past, if you've ever used our PBF, policy-based forwarding, we know that that's an exception to routing. And we could do source, destination matches, and applications, right? SD-WAN, I always explain it more like is PBF on steroids, right? We're still doing all of our routing by policies and by applications. So now with SD-WAN policies, we have a support for all applications, okay? We could do match criteria from your source, destinations, and we don't just look at your destination routes. But from a routing perspective, when you upgrade it to 9.1, you'll notice in your interface section, you see a new tab. It's called SD-WAN. So the SD-WAN interface is grouping for a routing from a destination route, right? You still got to have routes so we know what the egress interface is. So what we've done is we create these virtual interfaces. One is we call DIA, right? The direct internet access. That's typically for your clear traffic. That's where we have our default routes. Then we have a VPN SD-WAN VIF, right? So this is where we group together tunnel interfaces, right? Within a SD-WAN VIF, and then we have routings pointing to that. So we have different VIFs pointing to multiple hubs, right? Different branches. And then we have multiple tunnels that are built over transports. And then we're able to fail from one to another, right? We've had that multiple path failovers across multiple interfaces because we put the interfaces in a security zone, right? We don't really care about the interface. We care about the zone associated with it. So that allows us to be able to fail from one tunnel interface to another, right? Keep that traffic flowing, or from a clear traffic going out to the internet. So that's kind of how the flow is. Don't overthink that we ripped everything out. Think about we're just doing route exceptions, right? It's going to be policy-based routing, and the SD-WAN has all that logic built into it. So this is what it looks like in a, let's get to the final ones, and then I'll talk to the different parts, okay? So this is big picture. So our PAN-OS SD-WAN is a bookended solution, right? Meaning that we need to have a Palo Alto firewall at both ends. So the way we do it is you have your branch, you have your different transports, right? That's your underlay. So these are different WAN connections, be broadband, ADSL, MPLS, LTE, whatever flavor that you have to be able to talk to other SD-WAN devices, right? So to hit those internal resources. What we've done is we came out with this proprietary probing. So now from the branch, we'll send this probe through the tunnel over the transport to a hub or another branch. Through that probe, it gets sent and it gets reflected back. So we send 5 pings per second, right, every second to get that sub-second failovers. So it's about every 200 milliseconds that we're now sending this probe. So we can now measure the latency generated packet loss of those type WAN connections, right? These are more traditional ways of doing SD-WAN, but this is how we introduced it into PAN-OS. So we have these path quality profiles, and those are going to be ways to set your brownout or your trigger points, right, for latency generated packet loss. What we've done is we've went through and we predefined all of your application categories, right? And within those application categories, we set what we thought were the best trigger points for latency generated packet loss for those brownout conditions, okay? On top of that, your path decisions is now done by this traffic distribution profile, meaning is that we're gonna have ways for you to select which path to use first and what you can fail over to. Depending on how many types of WAN connections you have, you can make any amount of traffic distribution profiles, as combinations allow, right? So you can have some traffic use MPLS first and fail over to broadband, ADSL. You can have some just use broadband and ADSL, right? You don't want to use any MPLS because maybe some of this stuff goes to the internet. You can have some that has a broadband, which is your big pipe, least expensive, and then you have an LTE as your backup, right? Very expensive. And you can make different path decisions depending on the application, right? So we have the granularity to be able to set all these different traffic distribution profiles so you can pick the different paths. It's not just based on destination. You could base it off of a source match, right? Destination match and application. Unlike policy-based forwarding, where you had to stack a bunch of different policies and use host monitoring, where, oh, hey, here's one policy. Oh, I can't talk that path. Disable it. Now we can run through your PBF rules. With SD-WAN, you don't need any of that stuff, right? So SD-WAN, we're monitoring all of your different transport, and depending on the applications, we can pick which transport we're going to use first. We're now monitoring, so we can now trigger for a brownout condition and fail to whichever path that you have selected in your traffic distribution profiles. All of that can be done within the single rule. So I can have failovers within that rule. So I don't have to have a bunch of different rules because they're going to get disabled. SD-WAN policies are going to be able to build all that logic. We're going to be able to monitor all your connections, and you can make path decisions on size, bandwidth, cost, right, and things like that. So that's kind of what the flow is. We also in 10.0 introduced a SASE monitoring. So in addition to monitoring the transports between SD-WAN sites, right, we can also monitor applications out in the clear, right, like Office 365 and things like that. So from this branch office, I can still monitor applications out in the internet and be able to make path decisions on how those applications are running and be able to make changes depending on how those are reacting. So in addition to site for internal resources, we can also monitor applications out in the clear. But again, your troubleshooting is, did your IPsec tunnels come up? Look at your traffic logs, did session gets created? Because like most of our other policies that are under security, it's mainly for, how do we affect traffic, natting, how do we manipulate things like that. You still need to have your security rules because we're building the logical interfaces and applying security zones. So your security rules are still done by your policies, right? The SD-WAN logic is just how do I steer traffic out which interface and the ordering of that. Okay, so that's kind of the big difference between PanOS SD-WAN is that if you've already standardized on firewalls at those locations, if you need that local segmentation, so you want to get to that zero trust, as a question popped up I saw earlier, east-west, you already had the Palo Alto there, right? So you're doing east-west segmentation. You were already at the edge, so we already had the internet connections, right? So it's easier just to get the SD-WAN subscription on the firewall than it is to bring in the third-party SD-WAN device. So local segmentation, you already have the firewalls there. You don't have to backhaul everything, right? You get your less expensive internet connections instead of just using the MPLS. So, and you're doing everything that we've done ever since we started this 15 years ago. You have all of that. You have all the visibility. You have all the different things you can do with the firewall. And now we have better logic so you can fail over your different paths now on a quality, not just for blackout conditions. And that's what I have. Later on, they're going to go a little bit more over how Panorama ties everything together, how it's going to configure everything for you and do all the heavy lifting. So they're going to demo that later on, but that's what I have. Thank you for listening, and we'll look and see if we can answer any questions.
Great. Thank you very much, Byron.
Mm-hmm.
Katie, what do we have next?